Hello friends, our today's lab is regarding the IPsec tunnel. We are going to configure manual mode IPsec tunnel. Here um, we are going to establish an IPsec tunnel between these two sites, site 1 and site 2. We have two different networks on each site. Here we have 192.168.10.0/24 and 192.168.20.0/24 on site 1, and on site 2 we have 192.168.30.0 and 192.168.40.0 on site 2. We are going to configure the tunnel between in these two routers. Here we have um, two different VLANs on each site, VLAN 10 and VLAN 20 on site 1 and VLAN 30 and VLAN 40 on site 2. This interface 0/0 and the interface of router 2 is also 0/0. We will configure IPsec tunnel between these two interfaces. Our today's tasks are to establish an IPsec tunnel between site 1 and site 2, manually set up the IPsec essays. Okay friends, here you can see that and this system is assigned with an IP address of 192.168.10.101, and this system is assigned with an IP address of 192.168.20.101. Similarly, 30.101 and 40.101. Now we will configure our switch for the subject lab. Okay, let's start. Here, system view, host name. Our host name will be site1 switch. Site 1 switch. We will configure two different VLANs, VLAN 10 and VLAN 20. VLAN 10 and VLAN 20. Now we will assign uh, these VLAN to our interfaces of this switch. Interface gigabit 1/0/1 port link type access port access VLAN 10. Similarly, interface gigabit 2 port link type access port access VLAN 20. Interface uh, and the 48th port of this switch is connected with the router. We will configure this port as a trunk port. Port link type trunk port trunk permit VLAN 10 and 20. Save. Configuration of this switch is complete now. Now we will configure our router 1. Control C. System view. Host name will be our router 1. Interface. This is 0/1 gigabit 0 slash mm, mm, mm. Wait, we are going to configure sub interfaces here. Interface gigabit 0/1 dot done. We will configure VLAN type dot 1Q VID 10. IP address will be 192.168.10.1255255. Interface gigabit 0/1 dot 20 and VLAN type dot 1Q VID 20. IP address will be 192.168.20.1255255. interface gigabit 0/0 IP address will be. Here we are going to configure 1.1.1 as we are going to use this network on this link. So we will assign the first IP on this interface 0/0 of router 1. Now we will configure OSPF on this router in order to make all the networks accessible from one and other. So OSPF process ID 1 area 0 network 192.168.10.0 wildcard mask network 192.168.20.0 network 1 dot save. Configuration of our first router is complete. Now we will configure our second router. In this scenario, these two sites, site 1 and site 2, are connected via a public network. These two routers are showing our public network. So we will configure our public network here. System view, host name, public 1, interface gigabit 0/0 IP address. This is the 0/0 interface of this router. We will assign the second IP of this network to this interface. 1.1.2. Okay. Now we will configure our 0/1 interface, which will be assigned with an IP address of this network 3.1.1.0. We will assign our first IP on this interface. Interface gigabit 0/1 IP address 3.1.1.1.255.255.0 OSPF 1 area 0 network 1.1.0 wildcard mask and similarly network 3.1.1.0 okay network 3. Okay. Save. Our configuration of public network, first router of public network, is also completed. Now we will configure our second router. System view, host name, public 2. Here we will configure our 0/1 for this network and 0/0 for this network. Okay. Interface gigabit 0/1 IP address 3.1.1.2 interface gigabit 0/0 IP address is 2.1.1.2 255.255.0 OSPF 1 area 0 network 3.1.1.0 wildcard mask is this. Similarly, network 2.1.1.0. Now we will configure our router of site 2. System view, host name, router 2. Here we have 0/0 on network 2.1.1.0, and we will create our sub interfaces on 0/1. So first we will configure our interface gigabit 0/0. IP address will be 2.1.1.1.255.255. Now we will configure our sub interfaces for trunk port of switch site 2. Interface gigabit 0/1.30, as we have two VLANs here, 30 and 40. So accordingly we are going to configure the sub interface as 0/1.30. Here we will configure VLAN type .1q PID 30. IP address is 192.168.30.1255255.0. Interface gigabit 0/1.40 for VLAN 40. VLAN type is .1q PID 40. IP address as 192.168.40.1255. OSPF process ID 1, area 0, network 192.168.30.0, wildcard mask. Similarly, network 192.168 40.0, wildcard mask is this, and network 2. Our configuration of router 2 is also completed now. Now we will configure our switch of site 2. System view, host name, site 2, switch. Okay, VLAN 30, VLAN 40, interface gigabit 1/0/1, port link type access, port access VLAN 30, interface gigabit, port link type access, port access VLAN 40, interface gigabit, port link type trunk, port trunk permit VID 30 and 40. Save. Now let us check the connectivity on all the networks. Ping 192.168.30.101, it is accessible. Similarly, 40.101 accessible, and 20.101 accessible. All the networks are accessible. Now we will configure our tunnel. So first we will configure our ACL access list number 301 rule permit IP source. Okay, if I want this only this network to be passed from the IPsec tunnel for this network, then we will only define source IP as 192.168.10.0 and destination IP as 192.168.40.0. This is our HCL. Now we will create an IPsec transform set. IPsec transform set with any name, you can say test 1. Okay, encapsulation mode will be tunnel, as we are going to create a tunnel, and protocol will be ESP. ESP encryption algorithm will be AES CVC 192, and ESP authentication algorithm will be SHA-1. Now we will configure manual IPsec policy entry with the policy name call1. Say we are going to name it as a call CALL. Okay, IPsec policy. Here we are going to type the name call 1, number as 10, and it is CALL 1, number 10, and manual mode. Okay, here we are going to configure security ACL as 3001, as we configured here as 3001, and transform that as test 1. And now we will configure the remote IP address. For this router, remote IP address will be the IP address of this interface, which is 2.1.1.1. Remote address is 2.1. Now we will configure inbound and outbound SPIs for ESP. SA SPI outbound ESP 1 2 3 4 5 6, and SA SPI inbound ESP, which will be the opposite of the above given number 654321. Similarly, on the other hand, we will configure outbound as 654321 and inbound as 12345 6 on the router 2. Now we will configure the inbound and outbound SAS keys for ESP. SA string key, outbound ESP simple root, and opposite of root TOOR. SA string key inbound ESP simple. Here the inbound should be the opposite of this root, which is the same. This is the trick I did here. Okay, now we will um, apply this IPsec policy to our concerned interface, which is this interface 0/0 interface gigabit 0/0 IPsec apply policy call 1. Now let us check our display IPsec SA. Here you can see all these things have been configured here. Now let me configure the same thing on our router too. Configure the ACL access list number 3001 and rule permit IP source. Here source will be this network, which is 192.168.40.0 192.168.40.0 and wildcard mask is this. Similarly, destination will be the our this network VLAN 10 network. Destination with 192.168.10.0. Okay, quit. Now we will configure our IPsec transform set as test 1. Here we will configure encapsulation mode as tunnel and protocol as ESP. Now ESP encryption algorithm will be AES CBC 192. ESP encryption authentication algorithm will be SHA-1. Now we will create a manual IPsec policy tree with policy name as hello1. Okay, IPsec policy hello1 number 10 and is manual. QT will be ACL 3001 and transform set as test 1. Remote address will be the address of this interface. For this interface, this will be the remote address, which is 1.1.1. And now we will configure the inbound and outbound SPIs for ESP. SPI outbound ESP 654321 and similarly SPI inbound ESP 123456. Now we will configure the inbound and outbound SA keys for ESP. string key outbound will be sp simple root say string key inbound esp simple root and this. Now we will apply this policy on interface 0/0. Interface gigabit 0/0 IPsec apply policy hello 1. Display IPsec SA. Configuration has been done on both the routers. Let us check whether we are able to access our all the networks or not. Ping 192.168.40 dot it is accessible. Now let me show you another thing which will justify our configuration. Okay, now check on. We configured our ACL for the tunnel, and as per the ACL, only this network will be able to communicate with this network via tunnel. Okay, let me show you. Now, here you can see encapsulating security payload. And if we ping 192.168.30.101, then it will be the simple packet. No encapsulation will be there. Here you can see 192.168.10.101 to 192.168.30.101. No encapsulation here, whereas in previous you can see that the source IP is 1.1.1.1 and destination IP is 2.1.1.1, and it is encapsulating security payload. So guys, this is how you can configure IPsec tunnel by using H3C and HPE switches. If you have any question regarding this lab, you can ask me in comments. Thank you.